Should I start? Sure.
Yeah. So, very warm welcome, nice opportunity for our visiting professor, Professor Rodrigo Cádiz from the Catholic University in Santiago, Chile.
Right.
And he's been here holding forth with instruments, compositions, all sorts of mirth and classes, and we're delighted that you were able to come for this sabbatical, kind of extended, and have you around. So more to come. I think you're going to talk about a piece that's going to be on the laptop orchestra concert and such.
I don't know about that. We'll see.
You should plug it anyway, because it's a good thing to do. But yay, man, welcome, and
thank you.
Look forward to this. Yeah.
Well, thank you. Well, thank you. I want to thank you for the invitation. Actually, it's been a pleasure being here and getting to know all of you and getting to know the things you do, and that's great. I think it's totally great. So I just want to share a couple of things I've been doing for quite some time now. So I've been working on this new instrument since 2007, maybe 2008. That's when we started to think about this. So I want to tell you the story about it, because I think the story is interesting. Maybe the instrument is not yet at the level I would like to be. But the story, I think it's quite a journey, and I think it could enlighten some of you, or I don't know, at least provide a different point of view towards how do you design such a thing. So my instrument is called the Arcontinuo, and actually it's not mine, it's from a lot of people. I will just show you there how many people have worked on that. So, but the idea is to build an instrument from the ground up, starting from nothing actually, no preconceived ideas whatsoever. So, and try to deliver something that would compete with traditional instruments. That was our goal from the very beginning. So let me tell you a little bit about the story of this. So this is a multi-institutional, multi-faculty, as we would say, effort from people from engineering, design, and music. And first I want to acknowledge all the people that have worked on this, because it's quite some now. Even we hired a company to build the latest version of the instrument. And so thanks to all of them, the instrument now exists. And actually I want to acknowledge also that this is the work of Patricio de la Cuadra, who is a CCRMA alumni, so is already related to CCRMA before I came here. So let me show you the fundamental idea which we are based our research for this. So whenever you take an object, you can say that this is a quality object. This has some quality compared to other one which is not the same quality. But that's actually not true. Well, that's actually not the way we think. So quality is not a thing. It's not on a thing. Okay? So that's the basic premise of this. So actually it's an event. So quality emerges when you interact with things. It's not a property of things. Okay? So based on that, there are a couple of things here I want to mention. So based on that, it is important to understand how people interact with objects, how people will use an instrument, and if you take what people say, it's different usually from what people actually do. So we could have interviewed people and say, what do you want? We could design whatever they wanted to. But that's different from observing them using the thing, or using a similar thing, and that reveals hidden stuff, or things they're not aware of, they don't want to tell you, or that they're really, I don't know, for some reason, there is an incompatibility between what they are, and what they think they are, what they say they are, and what actually do when you have a task to do. So basically, I mean, I will refer you later if you want to know more about for the paper, but basically this translates into, sorry, let's proceed here. So into that we took from the very beginning, before this, let me tell you first the story about this. So there's a very good friend of mine who works at the design school in my university. And he was working with one of his students on a MIDI guitar. It was the worst thing I've ever seen. Like a guitar, just a guitar body with some pretty bad, faders and knobs and buttons. And he thought, because he's not really into music technology or computer music, he thought that was the coolest thing ever. So he showed that to me, and I said, there are millions of things like this. You will never get something out of it. And he could have left, totally angry with me, but instead of getting angry, he said, okay, well, let's do it the right way. So let's decide to do something and have a methodology from design that we could use that is not based on what do you want to design, but what do you actually research into. That's why it's called design research, what you get out of people, potential users. So we did for this, we started with a focus group. So we gathered 17 musicians. Actually, a couple of them were non-musicians actually. Some of them played an instrument, some of them didn't play an instrument, some of them played electronic instruments already. And we captured them in several dimensions. So we first talked with them, took all the notes they said to us about what they wanted in a new instrument. So the open question was something like, let's say we're going to build a totally new instrument for you. What do you want from it? And they said a lot of stuff. Then we went to analyze the data. We proposed them sounds to them. So because we talk a lot about sounds. Okay, so you said a lot of things about sounds. We wanted to figure out if they would actually were thinking right about what they really wanted. So in order to study that, we produced some sounds based on what they said, and they played the sounds to them, and we required them to imagine they were controlling the sound. Okay, and we videotaped everything. If they couldn't do a movement, they could draw it, or they could write something, whatever. And we took all that information and we gathered that. So this is the things we talk about. So we talk about the central circle are the concepts that most people refer to, and were the most important one. But we directed the conversation into different axes, like cognition. How difficult it is to learn this new instrument? Is it easy? Is it hard? How musical it is? How portable it is? Is it good or not for a performance point of view? How do you play it? And of course, they want everything. They want it to be rich in timbre, complex, ergonomic, that embraces human gesture, programmable, easy, difficult to play at the same time, light and portable, up front, so you can just take it and play with it. Okay, so actually they wanted everything. So, let me show you a little bit what I was talking about these videos we took of them controlling sound. So this is for a particular type of sound. So you can see them that we're filming them, and we blind them so they would not get shy doing this, and also because we didn't want them to be influenced by others. So we recorded a lot of sessions with them just producing the sounds, imagining they were playing those particular sounds. In this example, we're dealing with continuous change in timbre. That's the category specifically for this example here. So you see there's a lot of variety in what they're doing. They're not doing the same thing. They do different gestures. And even if they couldn't do the gestures, they could draw something. I mean, I tried to do this, but I couldn't do it or for some reason.
Is that the first time they're hearing the sound?
Yes. I don't remember how many times we do this kind of test because we did it repeatedly. I don't know if they got a second chance to hear them. Probably they did. I don't remember actually. But that was only to capture a lot of video and a lot of drawings, and also we gather everything they said to us, And then we analyzed the data. That took a long time. that's what students are for, right? You know. And so actually we categorize every movement based on this osteokinematic, chart of some sort. So we took that, I don't know, we classified every joint and every movement they could make with the joints in this kind of scheme with C means shoulder, D means elbow, and so forth. And then we took statistics and tried to determine which was the fundamental movement they were doing. And actually, this was the one. So the most fundamental movement is moving your arms like this, but also your elbows a little bit, and a little bit of this. And then the fingers. So it was this gesture, doing this, okay? And that's the most important piece of information we got from that. So if you think about it.
Is the popularity of each of these individual things being coded in your analysis?
Yeah, it's
like
kind
which
of.
percentage of times that people were
Exactly.
pantomiming a sound?
Exactly, so 77% of all movements were using this.
Yeah.
And also we combine probabilities. I mean, we combine, and I forgot the details about this. It's kind of more than 10 years ago, about combined movements as well, not only isolated ones. So if you think about it, how many musical instruments that you know about use this gesture?
Drums.
Yeah, could be. But we didn't want a percussion instrument, but
Game track.
Game tracks. That's all we can think about over here.
right, yeah, of course. Yeah.
Prove it now.
Yeah, but were you using them 10 years ago?
Yes.
Like, well, okay, well, maybe at the same time. So,
That's when they went on later.
Yes.
yeah. So we didn't know about game tracks, so we did some mock-ups of things that we thought could be useful, like, I don't know, this kind of thing here that could capture this gesture and you would move your hands around it, or some kind of castanets that you move with the spring in the middle or something, or I don't know. And then we did this kind of, white thing there, kind of a round thing that you can hang from your shoulders and you move your fingers like this. At first we imagined 2 different sets for different hands, so one for this hand and another with the hole in the middle actually. That's what the first thing we did. And then, sorry, I forgot one thing. So we did several iterations with them, and they decided the one they liked the most was this round thing here. So we built that in this kind of wood model that we used to take measurements. So now we took measurements of what is the right, curvature, the right height, right width, how do you hang it, and so forth, with different people with different heights, women, men, whatever. And then there are pictures of people trying to hold in them, and see how it felt, how the weight, if it was comfortable enough or so. And then after, we decided that was the shape. So this is the first time we had a clue about how this instrument would look like. We had to come up with the technology. So we wanted to do something that was continuous, 3D, so you can have X, Y, and Z pressure, and also curved. Okay? So we had to come up, yeah, sure.
Are you assuming that the player will be standing?
Yes, at first, yes. That was our original intention, that you would stand on stage, hang it, and play. Like that. So we had to come up with a very cumbersome technology which was based on magnetic sensors, and agreed that we had magnets on top of them in a foam kind of thing, and then we built some sandwich layers of materials to that and thing. It was kind of, we did it manually, soldered by hand, everything, just to try to test this idea. And we built our first prototype, which was called the Arcontinuo 416. That's the number of sensors it has. And then we validated. So I want to show you, I don't know why I have so many videos, but I just want to show you a little bit. That's Patricio playing it at the very first time it makes sound. Wow. And that's kind of the software we were using to track the fingers. So you can see with their fingers. And you can see actually the computer cable here, which is this thick and the kind of the old printer wire, all that stuff.
Is that Macho?
Yeah, yeah. Okay, let's switch to a better performer, like here. Now I'm just playing with it and make different sounds and try to see if it kind of worked. So that was our first one, and this is the same thing again, so I won't play it.
Those are the magnets, right?
Yeah.
Okay.
And then after several years of work, we actually showed this one at ICMC in New York, 2010. We actually took the instrument and showed it there. Magically it worked. I don't know how it worked, but it worked. Then after a while, we went back to our users, actually to more people, and we thought about, okay, we built the thing. What do you think about it? And then we realized that several things were not right. So we redesigned it. So things were obvious. We manufacture the electronic. Not all of it, because there was details that were left out. Professionally, with not sounded by hand and stuff like that. We try to make a lighter instrument, less, a narrower one. Also, we changed the wood for aluminum to try to get a different look, different feel. We changed the way it hung because it wasn't comfortable enough, the way you hang it on the shoulders. And this is kind of a render of what it was going to be before we built it, actually. Another one. We changed the way you're supposed to put it on your belly. That's the new electronics, I think. And then we produced a new version, Arcontinuo 520. And that's the one that I used for almost 5 years or something, doing several stuff with it. And actually, these are actually pictures of the actual instrument, where we also put this grid kind of try to tell people where you are visually, because that was something that was not incorporated well, it didn't work well. Actually, there is a video here. I don't know if it will work. No, I don't know, but I have the video open here. I want to show you a little bit of what this thing can do, just a little bit. So let me put that one again, because that was kind of important. So you could, of course, change things in X direction, Y, and Z. Sorry, I want to show you the first one. So we have pressure. You can change something about the timbre if you go in that direction, and you have, okay? And I want to show you, so which one? This one? Oh, sorry. Just to show how fast it is. You kind of respond, and also, sorry, a little bit here. You get the idea of how it works, right? So, how do you continue this? There's the other video. I can show you if you want to. And then what happened is that I was giving a talk. So there were several problems with this design. Magnets try to get away from the instrument all the time, because there were a lot of magnets put in a small surface next to each other. They were trying to get away from it, so magnets were flipped all the time. So that means the algorithm was not working properly. It was very expensive to do. That unit cost a lot of money to build. We were using a microprocessor at the time, so everything was actually happening on a computer outside the instrument that was doing all the finger tracking and all the MIDI handle data. It was a mess of a software thing. And I was giving a talk about this kind of a nerd night thing in Santiago, and 10 minutes before the talk, it just died. And it was 6 years old or something, so I think it was okay for it to die. So at the versions we were trying to get some money to improve this. So actually we got some money to go to Boston. So we went to the MIT Media Lab and we showed it to the Joe Pardizzo's people, and they gave us some very good ideas about how to improve this. Actually, one of the things that we changed totally is the technology, and I can tell you later about that. The technology we used was not good, so we needed something totally different. We considered some alternatives, but we actually decided to something again. Also, we wanted to do some new things, like take the wood again, which was nice, and we lost with the aluminum version, make it much cleaner, change the curvature, change the shape of it so you can not only hang it but play like this, on a table. Change the way you hang it without anything weird, but just use normal straps, normal guitar straps, for instance. We changed the electronics very much faster. Everything now runs inside the instrument, pretty much everything. So I just can now connect it to any MIDI synth and it will work. Hopefully it will work when you will do a demo for you. So, and we got money to build 4 of them. We have built 3 already, and we have the 4th. Oh, there was one version that I forgot to mention. It was kind of in between the last one and this one that Gay played at last NIME. Last time I was showing this as well. That was kind of a transitory version of it, of the new one. So this is the new one. I think that no longer exists with Tear Apart after NIME probably. So that's kind of a back view of the render again. So we wanted to change. We wanted to make it look much more a professional instrument. So this is not actually a photo, but a render. So this is how I imagine it would look like. So something very appealing to you, something beautiful, something with a nice shape, something that you can just be willing to play it because it's cool. So, and then we got Jordan playing it. So when he was here, I showed him the instrument and we talked a lot about it. And I got a lot of insight from what he thinks. And he critiqued it a lot. I mean, there are several things that are wrong, in his opinion, with this instrument. But still, I think it's a good, idea. I think we should just keep trying to improve it. One of the problems it has, let me show it to you actually. I have it here. So this is one. But this is the one I have here. So now you just take it, and you just hang it. It's much easier than before. So supposedly, something happened here. So here. So let's go here. And one of the things Jordan said to me, okay, this is the way we imagine it's going to be played, like this block thing where that's not rock and roll, so you have to hang it like that, So and he did it, and I think it's actually better, it's more comfortable. So let's see if I can make it work. So how do I change? Can I just change this to? If I mute it, okay, no, that's fine. So I will see if it works. We'll turn it on. Oh, I have to, connect it here. So I will now just, this is the cable. It only uses one cable, much better than previous versions of it. And it's just a regular USB cable, and it's sending MIDI data out. So you can just plug it into an iPad. Let's see. If I turn it on. So now it has some things that are nice. It has a light, which is the logo, turn to light, but it tells me information about the status of the instrument. So I can change parameters and the light will change different. So this is supposed to be sounding. So, because I muted it. So let me change, I can change presets here, so let me change it quickly. So I will put something similar to what you just saw. I think this is it. No, I don't think this is the one, sorry. Yeah, this is the one. So there are several, I can change pretty much how it works internally by just, doing different setups. So now I have the blue scale using GeoShred. And I can use the X, for instance, to sorry, I want to show you. Sorry. So I can add vibrato to it. I can use the filter. Also, I did this kind of pitch bend when you're the same way your shred works when you reach a zone, and then after a while you can just pitch bend, not immediately, and then you can switch to the next zone. So that's it. So that's the new Arcontinuo. So let me show you, return to the presentation, I think. So I cannot talk much about this yet because we're applying for the patent for this new version. So I cannot reveal some, at least on video, so many details about how it works. But there are some things you can read about from the instrument that I think are nice. We got a paper that in Design Issues about the design process, which is described in much more detail than I talk here. I think it could be of interest. There is a paper at ICMC, and there is also a paper at NIME that talks about this instrument. To summarize, this is a very interdisciplinary research field that combines things you already know, of course. And the source of funding we have had so far are this one. So this has been funded mostly by the university and the National Council for the Arts so far. So hopefully we will get some more funds to actually get this time the ready version for the market and start selling or something, I don't know. So our goal was from the beginning to design something that eventually somebody would walk into a store and buy. because it works well, because it's musical, because it looks nice, because so many things. So we're making progress slowly, but eventually we'll get there. So that's what. Do you have any questions about the instrument?
So where did you end up on the sensors? Which ones? This is not magnetic.
No, it's a different technology. I can tell you later.
You
Yeah.
can't tell us.
Not at least on the video, but I can tell you later. No, I can tell you later. Yeah. Well, so we don't have any troubles. Any questions about this?
Can you reconfigure the mapping on it?
Yeah. So if I change something here, I could, for instance, I guess that's the one. It will produce only one note. In the whole thing. So I could have more time to. And there are several different ways that work internally. So actually one of the problems I'm having is that for each patch I want to use, either in GeoShred or whatever application, I have to change a lot of stuff. So probably what I have set up here will not work on the previous patch, so forth. So we're lacking kind of a middle software, a middleware actually, where you can configure the instrument, send parameters back in, and then quickly, use, I don't know. And the nice thing about this is I've been trying to make it talk MPE MIDI. So it's sending all this information per channel. I'm trying to use the same protocol, so that's why it works fine with GeoShred, but it doesn't work in that mode with other applications yet. So I don't know. It's a work in progress from that regard. So, and yeah, Chris said I'm writing a piece for the laptop orchestra. The piece I'm going to present at the Pink concert is going to be for Arcontinuo and the laptop orchestra. So Arcontinuo kind of has a solo instrument with the orchestra behind it. So hopefully it will work and will happen. So I have, I don't know how much time do I have? Do I have more time?
Oh, yeah.
Sure. Because there's another thing I would like to talk to you about, which is something that I'm going to present on the next NIME, which is, I think I have it here, this one. So by the way, this is the paper for the design process of the instrument, so you may find interesting if you can find, or you can email me and I can send it to you, where it's explained in detail what were our assumptions, what we did, the whole process we took, and how do you measure the outcomes and everything. So, and this one, I've been working for a while. Sorry, what do I do this? I've been working for a while using fuzzy logic as a way to control several things in computer music, actually. And the thing I want to show you is just a quick demo, because I'm still, this is kind of work in progress, so I have to prepare for the NIME presentation 3 more weeks or something. And I haven't finished all the details of the demo, but I could show you more or less what it is about. So how many of you do know what fuzzy logic is, or at least what it's used for? You just Wikipedia?
It's been years since I heard the words of fuzzy logic.
Yeah.
Yeah, it was a big thing.
It's a big thing back a while back.
Yeah, I still have faith in it. Yeah, well, at the time when I was studying engineering, I could, people talking about neural networks as the same as fuzzy logic in terms of not the same, that they were equally important. That's what I mean. So
Coming back.
I think, yeah, well, maybe.
Or maybe machine learning's going to go.
So maybe, I don't know. So
Neural nets are quite fuzzy, actually.
So at the time I took the fuzzy logic road, I don't know why. It seemed appealing to me, and I think it still does appeal to me, although of course it's not at the same scale that deep learning is now, today. But the most important idea, I think, for computer music is that it's a very nice way to map multi parameters into multi inputs and into multi outputs. When you have a lot of inputs and you want to control a lot of outputs, which is typically the case when you have, I don't know, big things with a lot of faders and knobs and parameters, and you have your instrument which is also multidimensional. And of course, something like Wakinator that we saw the couple of weeks ago works fine with that. And I think fuzzy logic could be used in the same way. But there is one fundamental difference, is that actually you kind of understand what's happening when you use fuzzy logic. Or at least you have an idea of what you want.
Fuzzy.
Yeah, right. If you can build a crazy fuzzy logic patch, which you drag faders in and you will see output and you have no idea why. But if you go rule by rule and to understand what you did, you eventually have an idea of what. Now, to reach the same performance as a neural network today, you have to do a lot of actual fuzzy rules and I don't know, kind of a fancy system maybe, I don't know. But I want to show you a very simple one and show you how it could be used for. So actually, the one, I don't know if I want to show you something about this, but so I built this toolkit to use fuzzy logic inside Max and inside actually the first version was to use it inside Max and PD. And I think that I did that a while ago, and I published a paper at ICMC about this, and then I rewrote it because there were several things I wasn't satisfied with, and I wrote a version in Java, which I don't know if it was a good idea, but I did it. And now it works fine in Max. It theoretically works in PD because it's Java-based, so you can compile it for PD. I haven't done it yet, but still for Max works fine. And then I think about it is that you can have an external inside Max, and you can input your data, and you can output fuzzy data out of it, sort of. So, and now we're releasing the second version of the toolkit, which is in GitHub. So if somebody wants it, I can just give you in the paper is a GitHub address. I haven't finished all the examples yet, but I will show you the one I've been working for, demo it a little bit and how it could be used. So let me show you. But I asked what fuzzy logic was, but does anybody know what it is? So I can explain it a little bit.
Does anybody know what?
What fuzzy logic is? Did I explain that? I didn't explain that, I think.
I can read what Wikipedia.
Okay, no. So let me try to quickly here open something which I hope I don't regret. Open MATLAB to show you, because if you see it visually, you will understand immediately what it is about. So basically, fuzzy logic is based on this idea that we don't have to live on a world with you either belong to a set or don't belong to it. That's the way binary logic works. That's the way computers work. At the very fundamental level, that's the way logic works. You're either A or not A. So can you be partially A? Well, fuzzy logic says yes, you can be partially A. And the way they came up with this is that, fuzzy, that they created a way to fuzzify variables. So when you create in MATLAB, this is a MATLAB version, a basic fuzzy logic set, you have one input, one output. And the input is, they have what it's called membership functions. So you can think of this like as wave shaping kind of thing. So the input gets mapped to an output based on these Gaussian barrels. So basically a number here belongs to some degree, the height, to this membership function, which is called, it could be labeled as high, but at the same time belongs to that one with a higher degree of pertinence to that one. So if you label this low, middle, high, you can start talking like, oh, what about if this variable is high, or if it's low enough, or if it's very high, instead of actual numbers. So you start talking in kind of verbal descriptions of the thing. So you have an output which is also falsified, and then you have rules. In this case, I don't think there is any rule, but we can add one. So for instance, if we speak rules, you can add here one that says, oh, I need to add a rule. Okay, that's what I want to do, so sorry. So that's to view the rules. Okay, so let's say, so when the input is very low, for instance, I want the output to be very low, so I will add that rule. Here's one basic rule. When the input is high, nevertheless, I want the output to be medium. I don't know, this could relate to how force you apply to something that you're controlling, and then the torque of the motor or whatever thing. So it's been very useful to handle, controllers, like for the Ph.D. controller. I think you can do the same thing with physiology and it works just as fine. And you can add rules. In this case, it's a very simple one, so we have only one input, one output. And then the thing is that because you have these shapes, Gaussian and thing, the computation is nonlinear. So it's not a linear sum of the inputs. It's very nonlinear because you have these weird shapes and stuff. Also, the way you defacify depends on functions like the maximum or the centroid, or I don't know, or the minimum value of something, which are not linear. So you can come up with very highly nonlinear mappings of outputs and inputs, which is kind of the same thing that happens in a neural network. It probably will either be more strange or something, but it's the same thing, actually, basically. So. Can I open a simple one? Let's see if I can.
So you train it like a neural net?
I could show you the way it could be trained, similar to the way Waginator works. So that's what I want to show you. So let me first just quickly open. So where am I? So I want to go to. Dropbox. Software. I have here, not this one, an example, this one. So this is a more complete 2 inputs one. Is this the one? I think so. So let's see, but it already has the rules there, so let's try to view the rules of this one. Okay, so this is a graphical design. So this is only one rule in this very simple example. So you can know what will happen to the output when you move the input as well. So let me show you this, how it works inside PAX. So I have this patch here where I have my fuzzy toolbox working. So here, let's see if I have any input. So let me turn it back here. So okay. So what I have here is the Arcontinuo as well, and I have just, for this example, just the X, Y, and Z data. So 3 numbers. So I move down, the X goes down, and I move this way, changes, and I press, changes the value. And I have an empty fuzzy system with 5 inputs, 4 outputs. The 4 outputs are controlling a synth. If I can change this fader. So each slider does something to the sound. Okay, this is volume. This is one parameter. This is another one. So basically what you could do, there is a train mode here, right? So basically what that's doing is as the following. Because I'm using only 3 inputs, that means I'm not going to use those inputs. So I'm going to select a specific input I want. For instance, when I'm here, I don't know, when I'm that position, X and Y, I want something to happen to the sound. So I can hold that position, and I want the sound to be like this, for example. Pretty much the same thing as you do in Waginator. But the difference is that you're not letting a computer figure out whatever you're doing. You're just telling this. When I'm here, I want this sound to behave like that. And I don't want the volume to change with this because I want it to control with a different dimension. So just X and Y, and I add rule, and a rule was added to the system. So now the system knows that rules. It knows only one rule, one fuzzy logic rule. And then I change here, for instance, and I want the sound to change towards this. Okay? And I would say, oh, sorry, the weight was, this is the weight, that means how important to me is this rule. So this is much more important than the other one, so I will add this one. Okay? And then I will retrain this one, add a different one, so I wanted this here. And I could add an important rule here. Okay? And then when I'm here, I don't know, I want this. And it's equally important, I will add that rule. So there should be 3 rules in the system, 4 rules actually. If I print them, there are 4 rules here, which is the notation. I don't know if you see that, but tells me how the rules are behaving. And now let's train the CY, the volume. So if I want nothing to do with that, nothing to do with that, and I just want to train the volume here, for instance, I could just, it will be high when this is high, so add rule, it will be medium when it's medium, like here, and here, when it's low, it will be low. So now I have, in total, kind of 8 rules to the system. And now when I'm done training, I can just use it, and hopefully this will interpolate as I move the surface of the different values. And I could change the volume probably with that dimension which is independent from the others. Okay? So actually you can achieve the same thing, you can do the same thing you can do in Wikinator. Actually. The difference is not here is that you know what you're telling the system to do. So when I'm here, I want this fader to go up. When I'm there, which is the same thing, but if you take the fuzzy system and try to analyze it, you will understand what it's doing. It's not that hard to understand it, actually. It's very simple.
Also, the Wikinator wants multiple training examples.
Right.
You're just doing one example.
One. Of course, I'm not acquainted with the variation of this area, so I would probably add more rules in the vicinity of this to be more accurate. And I could add those rules if I wanted to. But because this is fussified, so this variable x will be very high and this will be very low, no matter if I'm here or in the vicinity. So only one example captures a whole region of possible values, depending on how the grid of the fussification you're using inside. And so yeah, that's one way to do it. Yeah, actually. So you don't require multiple examples.
So when you say a rule, what does that mean? I imagine a clustering classifier is like, you have a point in n-dimensional space and you want to associate it with another point in this output space of a different dimension, and that's fine. You can just get the whole space. But then you have a second example, and now you have to divide the space into 2, right? So it's like a linear discriminant. In other words, how do you implement these rules? Are they done by geometric clustering and separation planes, or is it some other? Is it really like a semantic rule, like in Lisp or something?
No, there are actually different ways to do it. There are 2 different models. One is the Sugeno model. That's one Bandami model, which basically, I don't remember the details right now, but they have the difference in how once you have the rules, how did you compute them one by one, and you basically were doing, okay, the typical method is the centroid. So because you have a rule that says, okay, if this triangle is activated and this other one is activated in some degree, so on that, I'm saying that the output, the triangle of the output is this one, okay. So how do I get a value from that? Let's take the centroid of this shape, and then you take that value out. But there's another rule that comes after that will change the same value probably. So how do you combine the 2 of them? There are several ways. You can sum them, you can make an AND of the rules, you can make an OR of the rules. And actually I didn't use it, but you can change this of an OR and an AND in the way you compute things. So there are several ways you produce an output based on what you want for your model, and actually will get you a final value. So The problem that I found with this is that if you don't add, you add, a limited number of rules to a system with a lot of variables, things tend to get in the middle of the output variables because the centroid tends to be there. So you have to add a lot of extreme examples to make it work properly. But it can be done. I mean, if with more time I could add more rules and fine-tune this.
So when you say syndrome, so an example is you trained it on 3 different inputs and got 3 different outputs, right? And now you press right in the middle, then it will do like a geometric interpolation. It's like
Or that depend on that would depend on the curves, basically.
Right. So
because I think that interpolation depends on kind of the initial. I think each input can draw out kind of its profile of membership. And
we're talking about, I was talking about point inputs, but now we're talking about trajectory
well,
inputs?
the point input in the middle, you give 3, you put in the middle, I think it has to depend on something you physically specify as essentially kind of a mapping curve, if I'm not mistaken.
Oh, I thought it was input output point, multidimensional.
But it is because it's like the high, medium, low, right? Because you have at any given point, it has some partial membership in one set, some other membership in another set. And I think how much it's a member of each set determines kind of how it's actually interpolated.
And normally that membership would be like a dot product or Euclidean distance. How is it done here?
it depends on the parameters. I want to show you the demo because I don't have a way to graph the rules in Max yet. I can graph the input and outputs, but not the rules itself. So in MATLAB I could do it if I can actually open the right demo probably, but it's hanging. So let's see if I try to find a more. Oh, here it is. It's opening. Okay. So let's simulate. Okay, this is what I want to show you. So this is a fuzzy logic system with 5 rules, and it's telling you for several. Oh, what happened? So let me reopen again because it's running now. Okay. So can I? Okay. So this is the important stuff. So there are 5 rules here. What happened?
I think your short-term memory.
Maybe. Oh, I'm sorry. I crashed my computer. Oh no.
There it is.
It crashed? Probably crashed. Okay. Let's just show you this. How can I stop? So,
They figure out fuzzy crashes. It shouldn't be so either or.
So here are different. So this is telling you which way to use the AND method, which could be with minimum or with probably the product actually. The maximum for the R method. How do you implication? How do you do aggregation? How do you do diffusification? Which are several ways to do this. 5 sector, centroid, and stuff. So I don't have a. I wanted to find a more complex fuzzy. Sorry, this is. I will have this ready for 9, but so let's see. Where's this one? This one is more complex. So where is this one? Okay. So let's open that one, and probably will make things clear to you. So this was in Dropbox Academic.
So see, the MathWorks has videos on the Fuzzy Logic Toolbox, which is a nice resource.
Yeah. Here I have several complex files. So SMC 2005, I have this one. Hopefully we'll have more. Okay, this is what I wanted. So this is a much more complex fuzzy system with, I don't know how many inputs, how many outputs. Hopefully there are rules here, so if I see the rules here, hopefully it's rendering. Here it is. So this is how it computes everything. So Let's hopefully this will work. Okay, so I have here, these are the number of rules that I have. This is the number of inputs, and these are the number of outputs here. So whenever the first input is in this real value, this rule is activated because it's yellow, is it? Yeah, sorry, this is activated. This is activated, this one and this one. So when this particular input is that value, there are only 4 rules that handle that. So that's why I'm saying that maybe you have no rule to handle that value, and then the output will be the mean, the centroid. So, and then for the other ones, and then what happens is that it computes, depending on how you set up this, the way to aggregate these 4 rules, which could be, okay, so let's take the output, what happened to the outputs here. So here it's the output that is predicting or actually generating from those actually, and if I change the first rule here, sorry, the input, the outputs should change here. So this was kind of this way, and this is now that way. But the way it computes this particular number here is based on, could be the maximum of the whole yellow shapes, or it could be, I don't know, other metric of how you combine them, maybe the multiplication, I have no idea. And that's kind of the research in this field. I mean, how do you do this and why and so forth.
So I think Wagner is a really good example with which to understand this. And to understand the difference is to kind of understand also what classification means. So would it be correct to say that I think on Wagner, what you get is you get kind of almost complete generality. You can have n inputs, n outputs, and inputs could be like a frame of audio. And you can have like 60, 600 inputs, and you don't care about how the curves go.
Yep.
And it's just like, if you're not happy with this, give it more training data. So in a sense, you're kind of always by example, essentially kind of drawing these curves without drawing the curves. Whereas here, it sounds like it's not as general, but what you get is that you do have this inside view, and you can get your hand inside the box and actually draw the curve. So,
and that's what I show you with this. I was looking for this one because this is what I like about fuzzy logic. This is a graph that shows how 2 input variables affect one output, and this is very highly nonlinear surface here. And if I change other input like this one with the other one, for the same output, this is the linear function applied to that value on the output. And this is for a different output, for instance, or this is for a different one. And all of these are happening at the same time, and they're being combined to generate the actual values of the output. So this is kind of looking at the neural networks, a particular layer of the neural network. And you have actually, and you have the function here plugged.
In this case, if you add, let's say you have 4 inputs, if you add an entirely new 5th input, it's a new channel of continuous data that's coming in, would you need to go in and basically by hand draw the
you will have to update all the rules because no rule handles that input yet.
Right, so you have to, would you add to the rule, do you have to like go through it and basically reconsider the whole map, the whole like rule space of what now with this new input?
Actually, you would need to do that, probably, yeah. That's why the way I design the object in Max is that you have to give it number of input, number of outputs. So hopefully if you change your mind, please restart from scratch with the new fuzzy model. I think. So but it's doable. I have functions that you can insert inputs and take out it, but it's complicated, but it should work. Hopefully it doesn't crash. But yeah, if you are thinking about design, and actually in the actual application of this technology, the actual value of this thing is what the rules are. So the way fuzzy logic started is that they asked experts. So we want to control this variable. What we should do with this valve here? Close it or open? You have to close it. Oh, so let's put that into a rule. But this is too high, close this one. But what happens if this is middle? We should leave it like that or no? A little bit, close it a little bit. Okay, that's expert knowledge. And you design it that way. You put rules that came from an expert, and then the system behaves.
Mixing engineer. Someone who's mixing.
For example, yeah.
For example, like 40 knobs, and you really kind of wanted, right?
This is
Yeah.
about the same time when there was also a lot going on with Bayes rules, as the same, probability based, I guess.
Yeah.
So, two phases of how do you combine.
Yeah. I've read papers where everything is introduced, everything written in physiologic, some authors, think of them as statistics or probability, and they interpret everything in those terms. This is the probability of that being that, if it was a random variable, if it will behave like this or like that, based on. It could be done, probably you can have, similar ways of thinking about this. But from the very first time I knew about this thing, I thought, this could be applied to creating music. I thought it instantly. how you can control outputs with inputs. And okay, so I'll publish this software, so it's available for everyone to use, and try to use it and see how it works.
Just that last MATLAB example, was that a music project?
No, I found it on my computer. No, actually, it was. Yeah, it was one of the. There is another paper we did in 2015, I think, where we created a fuzzy logic-based equalizer for audio. So I was using actually the fuzzy system where that's came from there, because that's what the folder where I drag it from. So I could, yeah.
So it was sort of a timbre experiment.
Yeah, well, it's kind of a strange idea. The idea is that this fuzzy equalization, this equalization curves that you get on your radio or your car radio or whatever. Pop should be like this, or iTunes will give you equalization. So they're different from each other, actually, from different vendors and stuff. And so we wanted to create something that could analyze what kind of music it was, and get the data from iTunes curved, So if it's another gender, it will get another curve. But what happens if it's in the middle? So we use fuzzy logic to interpolate between curves of. It was just an experiment. I don't know if it has any application whatsoever, but.
Jim above, when he was at Digit Design, was using applied machine learning for the same kind of thing. His idea was you have all these different interfaces, and for the mixing from EQ, basically a lot of this comes down to EQing, and he was making these crazy interfaces that basically can get an audio engineer like 60-70% of the way there, and then the rest is still you're back to the 40 knobs, and that's where the really human expertise kicks in. But you can get really reasonably high amount of that way you don't have to set all 40 knobs. It kind of sets them in the right rough region, and then you really use your ears to get that last 30% or even that last 10% that makes it really pop or whatever you wanted to do. So actually, if I can ask a question about our continuum. I've been actually wanting to ask all these questions, but I didn't want to. I know you had this other thing. Actually, I have so many questions. I would just ask maybe two. One is kind of this idea of the person's quality, and not as a property, but quality as an event, and how that ties into kind of the design of the art continuum. That seems like kind of this meta philosophy of art continuum, right? And is the idea that it's the meaning of the thing is created in the person who uses it?
Right.
Or is that okay? And is that what motivated kind of this
Yeah.
focus group, or what's the?
And also,
connection?
that's for sure. And in the saying that we want to build this, although some people will tell different things to us, but the idea is that somebody could buy this and personalize it in the ways that I want to do my own mapping, my own way of doing the presets, my own way of playing it, like in a table, like hanging this way, that way. That's one level of what we wanted to achieve. But also that the thing is that even just taking the thing and putting it, and it will work. It will work fine. So the quality is how you interact with it. It's a good interaction. It's not, the object itself is not, we don't think in terms of this is.
Would you say that's true for?
So for instance, you could have. Well, you could have a device that it's great, making these incredible sounds and with a lot of parameters and stuff, but maybe it's on a shape that it's not comfortable to you. You cannot put it. You cannot enjoy playing it. So that we would say, where is the quality there? The quality is not in the object; it's how you interact with it. So
that horrible MIDI thing that you're talking about, that there's the quality may be lacking. Because,
probably, yeah.
Precisely because of your encounter
Yeah.
with the thing.
Yeah, yeah. So another way to view this is that we didn't have any clue about the shape of this thing until we did all this study with users, and with people, and trying to get from them what would be the good solution.
That's actually fascinating because like I know the process. Like I encountered Arcontinuo first at NIME. I was like, this rocks. It feels good. It's very playable. And as an object, I think of that quality, I think now in retrospect was there. I'm actually kind of shocked that it went through a top-down focus group at some point, which I would say that's like the quickest way to like fail in designing something actually interesting. I think you've shown that you can actually get something. I've got this idea that there's some generalities, and I love this idea of blindfolding people to kind of see what they naturally do. And I think that there's actually research in like drone research of like trying to for people to gesture to direct drones, and what they do is they just film people with tasks like directing drones but actually not controlling them, and they go and analyze what they do. So it's kind of like backwards kind of design thing. I think that's so interesting.
Yeah.
But also, I guess my question here is that like, I feel like at some point though, this had a mind that really curated all the ways it had to be. And I think that mind perhaps is yours and your main collaborators. And you guys had to be like, you guys had like some alignment function in your brain.
Yes, that's true. No,
right?
that's not true.
So I'm trying to figure out where that balance was.
Yeah, actually, my colleague, which is a designer, he's the one. I mean, you kind of know this. But he's the one who defined the colors, the texture of this. He actually spent a lot of time looking at the actual, drivers. I mean, the bolts for this, because we couldn't find them in Chile actually. They were not black screws of this size for that kind of, precisely that kind of, and we have to import them and stuff. So he's trying to think all about the details from his point of view. He's the designer, so there is a lot of stuff that comes from.
Visual. I mean, also the action.
And where to put this and where to put the all those decisions, of course, are made by.
How elastic it feels.
Yeah, of course.
How much
Yeah, we spent many.
But that came from.
Times.
That came
Thank you
from
for.
the focus group. But that came from you guys, or what was the mixture?
It's been a 10-year process now, so probably thing happens along the way as well. But most, I would say, the first version was totally, a high percentage based on what users said, and then we will refine the idea until we get something that it's more playable and that behaves. We changed the surfaces many times, and this is different from the one you played at NIME. So we try to make it better anytime. And so there is a lot of improvement that you have to do in time for the instrument.
I'll save my questions for SLOrk.
Sure. I mean, sure. Well, thank you for coming. It was great being here.
First group with us.
Yeah, thank you.